Welcome to this demonstration of the CHAIMELEON repository platform. First, let me introduce that the CHAIMELEON architecture comprises local data warehouses in hospital and central repository. This central repository provides storage and processing and fulfills GDPR requirements according to the ethics requirements of the project. This repository exposes a set of services supported by cloud infrastructure to provide high availability, efficient access and online processing, ensuring the long-term preservation and security of the data, supporting repeatability of experiments fostering the reproducible science, and be compatible and is compatible with existing distributed infrastructure for research funded by other areas of the European Commission. So let me introduce first the three main concepts that has the CHAIMELEON repository. CHAIMELEON repository comprises storages, services, and applications. And we go along the concepts of user roles that have different access capabilities related to the storage and the processing. Datasets, which are a coherent and annotated set of images and the associated anonymized clinical data that have been given a persistent unique identifier. These datasets are citable research objects that are created and then released so they can be accessible for the people authenticated and authorized in the CHAIMELEON repository, and can publish the metadata in to be accessible in anonymous by anonymous users. So the data is always restricted to the authenticated users. The metadata can be publicly accessible in order to be compliant with the FAIR principles. This data is processed and accessed in situ in the CHAIMELEON platform by means of processing applications that can be deployed for inspecting, processing, analyzing, and visualizing the repository's data. So this is the outline of the demonstration. So we have a researcher that is Pau, who is a data scientist working on a research group of medical imaging at the Polytechnic University of Valencia. She's looking for a data set on lung CT imaging to perform an analysis. She's an expert on AI data analytic tools such as TensorFlow and knows how to program in Python. She likes visual environments such as notebooks and does not have access to a GPU at this moment. So here she heard about CHAIMELEON, so she wants to explore the possibilities. So the presentation, the demonstration will go through the following steps. First, Pau will access the system through anonymous user. Then she will realize that there are data sets that are of interest for her activity. At this point, she will register in the platform by using her IDP from her institution, request a user role, accept the terms and conditions, and access again to get the data directly from the platform. Once that she has logged in the system, then she will select one of the processing applications from the catalog that we have. In this case, she will select a Jupyter notebook, fill in the application details, including the request of a GPU provided by the repository, deploy the application, and visualize the endpoint of the application. Then she will access the application through this endpoint, and she will be able to browse the data, to process the data, and verifying that she has a GPU assigned so she can use it. So let's start with the video that demonstrates the process. So Pau visits the datasets explorer that we have in CHAIMELEON. She realized that she can see several datasets in which the metadata is publicly exposed. In one of them, she realized that there's information about lung CT, 422 images, and is relevant for her study. So she wants to sign up in the platform and get access to the dataset. So for this purpose, first, she would like to join to link the account that she has at her own institution, the Technical University of Valencia, with the CHAIMELEON platform. For this purpose, first she logs into her portal of her own institutions, give permissions to the CHAIMELEON platform for using the credentials, and then request for a role. Depending on the role, she will be able to access to perform some activities or another. She wants to explore data, so she's a data scientist. So she selects the data scientist, accepts the terms and conditions, and then validates the account, the email that has been associated to the account. Once it's validated, our security manager will receive the request and will then provide access and validate the account if the conditions are given. Once that Pau has the access, then she will be able to see not only the data sets that are whose metadata are publicly available, but also she will be able to see other data sets, but also will be able to access the data. She copies the reference of the data set and goes to the application dashboard. In the application dashboard, she will be able to select the platform that the application platform that she wants to use. First, she has to select the namespace in which the word will be organized. It's automatically created for her. And in the catalog, she realized that there's one out of the 7 applications that has Jupyter and TensorFlow. So she selects this one and wants to deploy a Jupyter TensorFlow notebook in order to process the data. She gives a name to this application, requests the GPU, and what is more important, pastes the link, pastes the identifier of the data set she wants to use. Then automatically the system will create an environment in which this data will be accessible, and only this data set through read-only and without copying through symbolic links. Once the application is deployed, as you can see here, the dashboard provides here with an URL, with a link to access the application. And she copies the link and goes to the browser to access the platform and therefore the data. So with this link, the platform requests a token. The token has been automatically created by the dashboard. So she has to copy the token and paste on the dashboard. So in order to ensure that only authorized users can access the application that she has deployed. And she will see that she has 3 folders, one folder with the dataset data and 2 folders with persistent home and a shared folder for sharing data with other researchers. So if she goes to the dataset, she can realize that there's she can see the 422 files and also the anonymized clinical data included as a JSON file. Then we will go to the terminal to see that the environment has the resources that Pau has requested, basically a GPU. For this purpose, she will run a very simple command, which is NVIDIA SMI, that gives the information about the GPU installed, in this case, a Tesla V100. Then she will go navigate through the different folders to see the data that is there. So in the folder of data sets, and with the identifier of the data sets, you can see that there's several folders that contain the information of the data. But it's much nicer to go through a graphical interface. So she will use one of the sample notebooks that we have prepared in order to access the same directory and process and visualize the data. So this simple notebook will fetch the data from the directory and visualize as images on the system. So we can just simply rerun to validate the process. With this very simple example, Pau has been able to access the data from in situ without having to download and providing the resources that she couldn't have at her own institution. As conclusion, the CHAIMELEON platform architecture is available and implies data providers and central repository. The central repository provides storage and processing for anonymized data and provides anonymous access for the public data, metadata that can be seen by users who are discovering the data available in the platform. So the central repository has been designed according to the extensive requirements elicitation process and is up and running, accessible through these endpoints that you have there and you can access directly. Thank you for watching.